Hello and welcome everybody. This is Noah, and in this video we're going to look at using greatest common factors, abbreviated GCFs, to find x-intercepts or horizontal intercepts, and we're going to just do an introductory example in this video. So if we want to start making sense of what any of this is even talking about, let me just read through a little bit here, and then I'll kind of restate this in my own words out loud. There are many instances where finding the horizontal intercepts of a function is much easier than using the quadratic formula. If we think back to using the quadratic formula in the previous lesson on trying to find the x-intercepts for a quadratic function, a lot of those can take a good amount of time, and in a lot of cases there are easier ways of going about finding those x-intercepts. And we want to develop some of these methods. So not every instance allows us to avoid the quadratic formula, but it does occur often enough that it's worth building up these other methods to save us time in the future. So this might seem a little weird. We have a method for finding them. Why do we need others? Well, we want to find easier ways. We want to save ourselves time in the future. And so while that might take a little bit of learning in the process, once we've done this learning, it's going to afford us a lot of time later on. So most of these other methods that we're going to be developing are going to involve factoring and then applying the zero product principle. So we want to talk about what those things are, what factoring is, what the zero product principle is. The first method that we're going to explore in this lesson specifically is called factoring out the GCF, or greatest common factor. Factoring is the process of rewriting a sum as a product, which we'll see many examples of moving forward. And the zero product principle, space here, is the fact that if two unknown things multiply to be zero, we know that one of those things must be zero. I'm going to write this out in another way as well. If I have A times B equals 0, then A equals 0 or B equals 0. One of those two things has to be 0 if they're multiplying to be 0. This only works with 0. It doesn't work with other numbers. The idea of factoring is a process of rewriting a sum as a product. So we're going to see many examples of this, but let me show, if I just had like the number 6, I can rewrite that as 2 times 3. That is a form of factoring. It's kind of weird because it's not a sum the way that it's written here, but it's still another idea that is factoring. We're rewriting something as a product that wasn't previously written as a product. So let's take a look at an application example to kind of get us moving here and see how this is actually used, not just in like a pure math, how to do math sense, but if we have an actual application that we're looking at where we might want to use this idea, and we'll go ahead and use it in this example. So our example says, take, for example, a golf ball which is launched off the ground from a height of 0 with an initial upward velocity of 48 feet per second. The height of the ball in this circumstance, in feet after t seconds, is given by h of t equals negative 16t squared plus 48t. Let me say that again. The height of the ball in feet after t seconds is given by h of t equals negative 16t squared plus 48t. So if we plug in a t value where t is in seconds, then this function is going to output the height of the ball that many seconds into its flight. So our goal is to find the t-intercepts of this quadratic formula, and we're going to interpret them in context of the scenario. So to find the horizontal intercepts, we set the function equal to 0. So 0 is going to equal negative 16t squared plus 48t. And we're just going to start this out by using the quadratic formula to solve this. So the quadratic formula is that t is going to equal negative b plus or minus the square root of b squared minus 4ac all over 2a. For this problem, we have a equal to negative 16, b is equal to 48, and c is equal to 0. There's no constant on here. This is a plus 0 constant that just isn't shown. So we're going to plug these values into the quadratic formula and simplify. We'll get that t equals negative 48 plus or minus the square root of 48 squared minus 4 times negative 16 times 0, close the square root, all over 2 times a is negative 16. We'll zoom in and work out this arithmetic. So one nice thing is that 0 in here, this will all go to 0. So we're going to have negative 48 plus or minus the square root of 48 squared. I'm not going to worry about figuring out what it is. The 0 cancels the rest out, so we'll have the square root of 48 squared, and then all over negative 32. 2 times negative 16 is negative 32. All right, so we'll take and say that on top we'll have negative 48 plus or minus the square root of 48 squared. The square root and the squared will cancel, so that becomes just a 48. So I didn't need to find out what the square was in order to simplify that. And then this will all be over negative 32. So I'll break this up as t equals negative 48 plus 48 over negative 32, or t equals negative 48 minus 48 all over negative 32. For the first one, we get negative 48 plus 48 is 0 over negative 32, which just equals 0. So t equals 0 is one of our values here. For the second one, t equals negative 48 minus 48 over negative 32. The top is going to be, well, negative 50 and negative 50 would be negative 100. But we're 4 shy of that, so this is going to be negative 96 over negative 32. And that's nice because 96 is exactly 3 times 32, so this is going to equal 3. So we have the t-intercepts are 0, 0, and 3, 0. We want to interpret these still, so let's take a second and do that. This is saying that at t equals 0 seconds, the height of the ball is 0 feet. That is, it's on the ground still, right? It hasn't left. That's the moment that we're hitting it, so it's still on the ground at that moment. And then at t equals 3 seconds is when the ball lands, right? Its height is 0 again, 3 seconds into its flight. So we hit the ball and go 1, 2, 3 seconds later it's hit the ground. All right, so that's why we would want to find a t-intercept in a case like this, is how long is the ball in the air? What's the flight time for this projectile, this golf ball that we're smacking into the air? But there's an easier way to do this, and the reason we did it using a quadratic formula is to show you how much we can appreciate this other method when it can be used. So we're now going to find the t-intercepts again. And these instructions are off. Fix this 1 second. There we go. It should say, find the t-intercepts of the same function by factoring out the greatest common factor and using the zero product principle. So what we're going to do is we're going to set the height equal to 0 again. To find the t-intercepts, 0 equals negative 16t squared plus 48t. And what we're going to do is we're going to write now 0 equals negative 16 times t times parentheses. And inside these parentheses, we're going to have a t minus 3. And the reason we get this t minus 3 is we say, if I were foiling this back out, or not foiling, but multiplying this back out, we would have negative 16t times t is t squared, so negative 16t squared, And then we would have the negative 16t times negative 3. The negatives would cancel. We'd get a plus. 16 times 3 is 48. And that t comes along with us for the ride. So if we multiply it back in, we get that same thing as before. So we're factoring out, we say. We are factoring out the negative 16t. So let's look at this again. I have negative 16t squared plus 48t. And I want to say what number goes into both of these coefficients. So when I look at this, I have negative 16t squared and a 48t. And it might take a second to realize, but 16 does go into 48. 48 3 times. So that means I can pull out a 16, and we like to pull the negative out if there's a negative in that first term. If I have a leading coefficient that's negative, I like to pull that out as well, always. And we'll see more examples of this as we move forward. I also want to note that there is a t is in both terms, that there's a t in both terms. So I can pull one of those out also. That's what we call this, pull out a t as well. So this, write down a t, and then we open parentheses. So I'll open parentheses and say what's left over, and put what is left over for each term. So if I factored out a negative 16t from the first term, the negative 16 is gone and one of the t's is gone. So we have a single t left over. And then if I've pulled a negative out to the front, the plus becomes a minus, so that when we multiply it back in, the negatives would cancel each other to be the plus 48. So the reason I have a minus here is because we pulled out a negative, changing the sign of both the t and the next term, or the 48t's being factored now. So the 48t, we've pulled out a 16, so 48 divided by 16 is going to go here. And 48 divided by 16 is 3. And we've pulled out a t, so there's no t left now in this term. So that's how we get the t minus 3 here. So that's how I was getting this negative 16 times t minus 3. So that is the factoring out the greatest common factor. And just so you know, we're going to have the next lesson is going to be over just practicing doing that, right? Here, we're doing it in context of an application, and we're just seeing it for the first time. And then we'll give you some practice of just the math part of that before applying that to another application. All right, so I'm going to go back and look again at 0 equals negative 16t times t minus 3. And the zero product principle says that if all of these things are being multiplied, one of them has to be 0. So either negative 16 equals 0, which it doesn't, or t equals 0, or t minus 3 equals 0. So if I say, okay, I've got t equals 0 now, that's good. That's one of the numbers that we'd come up with before. And for the second one, if I just add 3 to both sides, I get t equals 3. And so once again, we get the t-intercepts. Oops. The t-intercepts are 0, 0, and 3, 0, just like we found in the previous part where we did this with the quadratic formula. Okay. That's pretty much it. This video is getting a little long, but I do want to say one other thing, is that because I was talking through how this works, it felt like it took a long time. But let's run through this one more time and see how quick and simple it really is. I have 0 equals negative 16t squared plus 48t. I recognize that negative 16t can be pulled out, and I'm left with a t in the first term, and then 48 divided by negative 16 is minus 3, and the t got pulled out, so we're done there. And then this means that either t equals 0 or t minus 3 equals 0, so t equals 3. So in practice, it is this quick. And if we compare that little 20-second amount of work that I just did and compare it to all of the work that we needed to do for the quadratic formula, we can see that this can be very valuable as a time saver in the future. All right, I'm going to note that there is no now you try problem for this. This is just an introductory example to show you what this is and an application to show why we're learning it and how it's valuable. And I hope you appreciate that. In the next video, we'll go ahead and start practicing factoring out the greatest common factor to find horizontal intercepts. Thank you so much for watching, everyone, and we will see you in a future video.